This is the fifth in a series of videos in which I'm developing a 40-channel logic comparator. In the previous videos I started off with a prototype single channel for this unit. Then I went through the general layout and design ideas, and in the previous video I got as far as ordering the prototype boards. The prototype boards have now arrived. So firstly we have the display board. So if you have seen the previous videos, then you'll know that this is a multi-layer design. So the display board is responsible for hosting the connector for the test modules that host the reference chip. And on the back of this we plug the main socket that accepts the reference chip modules. So if I've done this correctly, this should now sit in this connector slot. Obviously it's upside down because I wanted the module boards to be underneath the top layer so that we can see the LEDs. If I put it on the top, then of course the LEDs would need to be further out, and they'd be further away from the pins on the chip, so making it less practical. So this should fit in here, which it does. So we now have a place to plug the modules into. So once we have the main socket in place, then this is obviously where you would plug the module cards into. So the module cards come in from the front, but they sit behind the display board, and then it plugs into this socket. And if it's plugged in, I've done my measurements correctly, it should line up and the device should be accessible through the aperture in the display board. So if you had a 40-pin IC, for example, and that was in the module, then it would sit like this, and then there's an LED adjacent to each pin. But it would be fairly difficult plugging the boards in, because there's obviously going to be a sandwich here of this board and then the boards that sit behind it. So I've also made some guides. These are 3D printed, and I will be supplying these as well. So I'll just get these screwed in place. The sharp-eyed among you will have noticed there's a cutout on one side of the modules, and that is repeated, or there's a mirror of that in one of the guides, so it prevents the module being plugged in the wrong way around. So I'll just get these screwed to the display board, and then we'll look at the rear boards. Okay, so that is the guides screwed to the board, and that will now accept the test modules. So you just slot the test modules in from the top. As I said, there's a stop on one side. It does two things. It stops the module in the right position relative to the LEDs, but it also prevents you from inserting the module upside down. So that pushes in, clicks into the connector that connects the module to the display board, and as you can see, it also correctly locates the LEDs adjacent to the pins on the devices that you're using as a reference. So once you've got this, the next thing is the comparator boards. So you can fit one or two of these. If you fit one of these, then it will be a 20-pin device. So in other words, the top 10 pins on each side will be active, and you'll be able to test anything up to 20-pin ICs. If you fit a second comparator module, then that will enable all 40 pins. And the way they connect is you'll use just simple connectors like this. So it doesn't matter which way around you put it, whether you put the pins on the display board or the pins on the comparator modules, and then of course the matching part would go onto the comparator module. So I'll just plug these in. Okay, so once it's plugged together, you've got a nice sandwich with your display board and the comparator board. If you want the 40-pin version, then all you do is you get this second comparator board and plug it into the bottom, so it will sit about there, and that will give you all 40 pins. Use this standard type connector, so there's nothing particularly difficult to find. The only unusual connector is the one that the test modules plug into, but even they're fairly easy to get hold of. They seem to be fairly common and quite cheap at the moment. So I'll be supplying these either as a bare set of boards or as a mini kit like this, where it will be the boards and the connectors, and then of course when it comes to the reference modules, you'll just buy these boards as and when you need them. They'll be fairly low cost, and configuration of these is fairly easy. You can see the little solder jumpers much easier than using plug-on jumpers, and the other reason I took this approach is if I use plug-on jumpers, I'd either have to move the LEDs further away from the device that's the reference, in which case it would be harder to see, simply because the jumpers will be too tall to fit between the test module and the underside of the display. So that's it for the moment. You can see it's progressing well. I'll assemble the unit, do a bit of testing, and then hopefully can demonstrate it working in the next video. I just thought I'd show one of the modules with an IC inserted into it, so you can see how it all sits together, and then, as I said, this will then plug onto the display board, and as you can see, the pins on the IC line up with the error indicator LEDs. Any comments welcome. If you're interested in one of these, then please let me know.